My name is Laurel Ruma. I'm with O'Reilly Media, and we're in Barcelona at the Velocity Conference. I'm here today with Ben Evans, who's the author of Java in a Nutshell, 6th edition, but is also one of the speakers at Velocity. His session was Performance is a People Problem, and my question was, what are the three main kind of takeaways from that? What are your three points that people need to know about?
Okay, so when we talk about performance being a people problem, what we're really talking about are two separate aspects of that. One of which is what are called cognitive biases. And there was a great session by Jonathan Klein from Etsy, also at Velocity this year, about an introduction to cognitive biases and how they affect engineering teams. But I want to sort of focus on just a couple of different biases which people have. First of all is a thing called confirmation bias, which is where people set out to do a performance exercise and they kind of expect they're sort of begging the question. They're sort of expecting to get a particular result or answer to come out of that. And so, of course, when they do the analysis, they look for the pattern that they're expecting in the data, and that can be a very, very harmful way of approaching performance problems. You should try to see the data, as neutrally as possible, and instead try to see what patterns are actually there, rather than imposing what you expect to see on the data. The second one is a type of cognitive bias which is overly reductive thinking. And the idea behind this is that modern software systems are incredibly complicated. So it's very hard to break them apart into very small pieces and then reason about the small pieces and then somehow have that reasoning build up into a conclusion that you can draw about the whole behavior of the system as a collective or as an aggregate thing. Unfortunately, developers very often suffer from reduction bias and often think that if they can just tweak some very low-level aspect of the system, that they're going to see a lot of performance change. So those are probably, I think, two of the biggest problems we see. The third one is simply communication. To do performance well, it's a truly cross-functional activity. And in fact, there was, I think, another talk about cross-functional teams at Velocity, which is probably on the live stream somewhere. But it is the case that people do still tend to think mostly in terms of individual silos and individual functional groups. You have your QA group, you have your operations group, you have your development group. And to do performance well, you actually have to cut across those boundaries, and the communication and the ability to see what other people are doing and to see the ownership of production and production performance as something which is collective, a collective ownership of that. That requires very, very strong communication between the teams.
Can you give an example of a team working really well together and what you would expect to see?
What would you expect to see? Well, in this case, what happens is you have monitoring data which is being collected. So you can take any, and that is then being reported on, and those reports and analyses are being shared back across the whole team. So the first key thing is, are we monitoring the system? Are we producing data and metrics? Are we analysing those metrics, and are we communicating them back across the whole team? That's one sign of a team really doing it well. Another one would be a team which understands how its systems are operating at a normal level. Because if you don't understand a baseline of the system when it's behaving itself, how do you spot an outage when it happens? So those are probably my two biggest examples of when you can spot a team that's doing it right.
That's pretty important. Thanks very much, Ben.
Thank you.